So let us come back and do the 2010 paper. So we've already done one identification question. Here also they've given the same question, right? So 2009 and 2010, I think, I don't know why, they've picked up the same question, they've repeated the same in both the papers. So you can watch for this question, 2009 paper. Please watch the video, which is done in 2009. Both are the same questions. Right, so let us do with the first one. What do they give us? They've given us, explain the mechanism of a nucleophilic attack on the carbonyl group of aldehydes or ketones. Okay, mechanism they've asked us. Nothing much big, simple basically. What do they ask me? I have to show either with the aldehyde or ketone. First, try to make a plane. First, write the heading. That is better. Just write mechanism of nucleophilic attack on carbonyl group of aldehydes or ketones. Okay, I am done with the heading. Why am I writing the heading? If I write the heading, the examiner clearly knows, okay, at least if you write the question number wrong, the examiner at least knows that you are answering to that particular question. Yes. So first important thing, try to make a plane like this. Right? This is your planar. In that, you're going to take the carbonyl group, the rear end, and this is one more. You have your double bond oxygen, carbonyl group. Now, the nucleophile is going to come and attack from the top face. First important thing, this bond is going to shift towards oxygen because of the electronegative nature of oxygen, and thus this gets partial positive charge and this gets partial negative charge. How does this look now? This is the step 1. Step 1. And this is the rate determining step, hence it is the slowest step. Now, this is right, slow step. And once this attacks from the top, how does this molecule look? The molecule, if I have to draw, right? Your carbonyl group is there, tetrahedral plane. Now this is your planar molecule. Now your carbonyl group is here. You have both the bonds here towards your side. And what happened now? This oxygen has got a partial negative charge and this nucleophile has come and attacked it from the top. Done. Now what am I going to do? I'm going to further perform the step 2 because I have to get the addition product, isn't it? Step 2. Step 2 is a fast step. In this I'm going to add H+. This H+ is going to go and attack your electronegative oxygen atom. What do I get then? I get carbon is here, rear end, and one is nucleophile and one is OH. That's it. This is called your addition product. And what is this called? This is your tetrahedral arrangement. Tetrahedral arrangement. That's it. You're going to show the nucleophilic addition in this way. So let us come back and do the 2010 part B question, right? Basically, you have your choice in your 30 marks. Earlier we used to have 30 questions. There you had choice between part A and part B. Again, part A had 5 questions and part B had 5 questions. So this is the 2010, the part B question. So what do they give us? They have given us the chemical test to distinguish between ethanol and propanol. Okay, the same story again. Here both are aldehydes. Fine. So when you have an aldehyde and a ketone, you would have told that aldehydes responds to Tollens and Felling's test and ketones do not. But how do you answer when you have both aldehydes, right? Basically, whenever you have 2 aldehydes, remember one important thing. Yeah. Your aldehyde and aldehyde, in that also you have variations. Your ethanol, right? What is ethanol? CH3CHO. Your primary aldehyde, right? Isn't it? You have 3 hydrogens in ethanol. That primary aldehydes will respond to your iodoform test and propanol doesn't respond to your iodoform test. Remember ethanols. So I'll write the first question. Copy the first one. Ethanol. Second one, propanol. So write both. Write the formula for both. Your CH3, CHO. You have your CH3, CH2, CHO. Now observe carefully. This is your alpha hydrogen attached to your aldehyde group. Right. Now here what do you have? You have alpha and beta. But here ionizable hydrogen atoms. Right. So ethanol shows iodoform test. This does not show iodoform test. Remember that. Now, for iodoform test, I've already done in one video that is numbered as 30. Video number 30. Please watch that video. You will get that iodoform test in that. So, I'm done with the first one. Let us come back and do the second one. So, the second one, what did they give us? I have to differentiate between phenol and benzoic acid. I have again done this in the earlier question paper only. That is your 2009 paper. I have all clearly shown phenol and benzoic acid responding to neutral FeCl3 test, where phenol gave a violet color precipitate and your benzoic acid gave a brown color precipitate, right? So please, that is your ferrate phenoxide ion complex. It is formed, and please watch that video for 2009 paper. This is also done. Now let us come back to the next. How do you do the following conversion? Okay, again a conversion question. Let us solve this. First one, what did I do? I have to solve this benzoic acid to benzaldehyde. Okay, let me take benzoic acid, COOH. This is your benzoic acid. What should I convert it into? I have to convert it into benzaldehyde. Right. Let us write benzaldehyde. This is your benzaldehyde. Done. Now, so whenever you have benzoic acid, now let us see what is extra. Here you have acidic group, you have an aldehyde group. One oxygen has lost, which helps us of how can I remove oxygen from something? When I use a reducing agent. That is one concept. Okay, I can remove oxygen and add hydrogen to that. That is one option. Second option is whenever you find your acidic group, right? Simple, easiest one. You can add PCl5. What does this PCl5 do? As we have seen, it's going to form an acyl chloride and POCl3 and HCl comes out. That is what we have done in PCl3 or PCl5 reactions. Why did I do this? Because once when you add PCl5, it's going to form an acyl chloride, COCl. Right? Now, what is the leftover product? The leftover product is POCl3 and HCl. 3 plus 1, 4 and 5. Done. Now simple, isn't it? What is this compound? The acyl chlorides, when you perform a reaction called Rosenmund reduction. Rosenmund reduction, I've already done this again. Rosenmund reduction in the presence of palladium and barium sulfate. Remember, what is this doing? It's going to remove this chlorine, correct, and add hydrogen. What does it do? It's going to we are going to take hydrogen like this. One hydrogen comes out as HCl. Yes, and one more hydrogen goes in adds, giving us benzaldehyde. This is how you're going to convert. Simple, easiest way actually I should say. First, take this, prepare an acyl chloride and use one name reaction, that is Rosenmund reduction. You will finally get the product. I'm done with this. Let us start with the second one. So again, the same thing, ethanol. Aldehyde reactions, ethanol to benzaldehyde, they said. Right. So ethanol to but2-enol, right? So I have to do the second one. Now, right, copy the question. Ethanol to but2-enol. Again an aldol condensation reaction. So write there aldol condensation. Right, all these you can solve unless until you complete your chapter, then only please come to board papers. Otherwise everything will be Greek and Latin for you all. So let us start. Ethanol. I have to take, no, ethanol I'm writing like this. Yes, simple. Again I'm going to add, as we did earlier, 1 more mole of acetaldehyde. First, this is going to shift and your hydrogen will come and attack this oxygen. And what do you get? This occurs in the presence of dilute sodium hydroxide. So no, what product do you get? You get CH3, your carbon, your oxygen with hydrogen, because I've shifted one from the alpha hydrogen, and you still have hydrogen and you have CH2 and CHO. Correct. Now what do? We are going to eliminate water from this. How do you eliminate water? There is one hydrogen here, isn't it? 2, I am writing one more that particular hydrogen in this way. So it's easy for me to eliminate. This H and OH comes out with this bond, and this bond is going to drop here. What do I get? I'm going to get a CH3. Let us see. I'm going to get an alkene or not. Which alkene? 1, 2, 3, 4. But. 2. Enol. Okay, I've got the product required, isn't it? But-2-enol. Simple. I've done the aldol condensation method and I've shown the formation of your but-2-enol from acetaldehyde. Your reaction is done. Your conversion is done. Second also is done. Let us do the third one. Now, propanone to propene. Okay, simple. Okay, let us do. I have to take the third one. So, copy the question again. Propanone to propene. So propanone formula CH3 C double bond O. This is your propanone. What should I convert it into? I have to convert it into propene. So they have not mentioned 2 propene or 1 propene. Okay, let me write this as like this. Not a problem because they have not mentioned it to me. Done. This is your propene. Now I have to convert this to that. Now what else? What is extra? Let us see. Now here there are 3 carbons. Here also 3 carbons. Not a problem. But here there is oxygen. Here there is no oxygen. Second point. Third, here there is no double bond. There is a double bond. Now first I have to remove this oxygen. Then only I'll get that. Right. So what should you do to remove oxygen? The best method is usage of reducing agents. Reducing agents will remove oxygen or add hydrogen. So use a reducing agent like lithium aluminium hydride. What is it going to do? It's going to add hydrogens. How many hydrogens? 2 hydrogens, where 1 hydrogen adds. Now this is going to shift here. 1 hydrogen adds to this oxygen and the second hydrogen adds to this carbon. How does this look? This looks like your CH3 C H here, OH here and CH3. I am getting a secondary alcohol now. Now compare. Still I am not done with this alkane. Now what is extra? Almost I can easily, I think if I take water, isn't it? If I take out water from this, I can easily remove, I can easily get double bond. Yes, to take out water, what are we going to do? You can use a dehydrating agent, that is dilute sulfuric acid. So what happens here? When you remove, you have to remove water, OH from here and H from here is going to get eliminated. So what will happen to this bond? This bond is going to shift here. CH3 is here, CH is here, CH2 is here. What did I get? I have got propene and from your propanone. That's it. This is how we are going to do the conversions.